We humans are rather basic. No, I am not going to give you a lecture on philosophy. I only mean to tell you that our blood has a variety of acids and bases and that our body pH is close to 7.4 at all times. And it is critical to maintain the pH of the blood because if the pH goes beyond a narrow range of 7 to 7.8, it can also be fatal. And it's the exchange of oxygen and carbon dioxide that maintains the pH of the blood. What is pH? How can we control pH? Let's find out in today's episode. Hi, I am Devabrata Goswami. Welcome to Chemistry. Today, we are going to discuss the ionization of water and its ionic product, concept of pH, and get an elementary idea about hydrolysis of salt. In the end, we will take a look at exam trends in the exam decoded section. You must be wondering why I have got these soap bars in my chemistry class. Did you know that the soap you use may not be compatible with your skin? Well, that's because our skin has a pH of 5.5, making it acidic. But soaps contain varying amounts of lye, an alkaline substance. So, get a soap that's rich in lye and, you guessed it, a high amount of lye can damage the acid mantle or protective layer that holds moisture in the skin. Today, we will define and understand pH, but before that, let's understand ionization of water and its ionic product. As we all know, pure water is a poor conductor of electricity. This shows that it is a weak electrolyte and hence it ionizes to a very small extent to give hydrogen ion and hydroxyl ion. Water also has a unique ability to react with itself to produce a hydronium ion and a hydroxyl ion. This is called self-ionization or autoprotolysis of water. During self-ionization, water acts as an acid as well as a base. We know, according to Arrhenius' theory, a molecule which donates a proton or a H+ ion is deemed to be an acid, and the species which accepts this proton is deemed to be a base. In pure water, the situation is unique. One water molecule donates a proton to act as an acid and the other water molecule accepts a proton to act as a base at the same time. So next time when you drink water, think about its unique properties. But if water is self-ionizing, it must also have a dissociation constant. In this case, the dissociation constant is denoted by K and is the ratio of the product of concentration of hydronium ion and hydroxyl ion divided by the square of concentration of water. Since water is a weak electrolyte and dissociates slightly, the concentration of water can be taken to be constant. Therefore, the expression becomes K multiplied by the square of concentration of water is equal to the product of concentration of hydronium ion and hydroxyl ion. The factor K multiplied by the square of concentration of water is given a new term Kw, which is known as ionic product of water. In your examination, you could be asked a question based on this concept. For example, what happens to the ionic product of water if we increase the temperature? Does it remain constant or does it change? The answer is that ionic product of water is constant only at constant temperature. With the increase in temperature, the value of ionic product of water increases. Its value at 25 degrees Celsius or 298 Kelvin is found to be 1.008 into 10 to the power minus 14 molar square. For simplicity, we usually take the value to be 1 into 10 to the power minus 14 molar square. In pure water, the concentration of hydronium ion is always equal to the concentration of hydroxyl ion. Substituting this in the expression of ionic product of water, we get value of concentration of H plus and OH minus ions to be 10 to the power minus 7 molar. This is one of the most useful relationships chemists have discovered. The expression for ionic product of water gives a simple relationship between hydronium ion and hydroxyl ion concentrations in all dilute aqueous solutions. To measure a value of 10 to the power minus 7 is a difficult task. So, a convenient method used to measure this is that of pH. Do you know who suggested this pH scale? Give this a thought or log on to www.topperlearning.com. I'll be back after a short break. Welcome back after the break. Before going for a break, I asked you to name the scientist who suggested pH scale. I'm sure you all know him. Søren Peter Lauritz Sørensen is the man who suggested a method for expressing the hydronium ion concentration on a logarithmic scale, which is known as pH scale. This scale makes the measurement of acidity and basicity easier, and sometimes that is very critical. Remember, I had said that our blood contains a variety of acids and bases that gives our blood an average pH of 7.4. And if the pH changes, blood becomes more acidic or more basic, which results in malfunctioning of all metabolic processes. The pH of a solution is defined as the negative logarithm to the base 10 of the activity of hydrogen ion. For a dilute solution with concentration less than 0.01 molar, the activity of hydrogen ion is equal in magnitude to the molarity. So, pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration. Keep in mind that pH definition is designed to give us convenient numbers to work with. The negative logarithm of the hydrogen ion concentration gives us pH whose value is positive, and it is a really useful number. For one, you can determine the nature of solutions. For example, solutions with pH of 7 are neutral solutions. The ones with pH less than 7 are acidic solutions, and the ones with a pH greater than 7 are basic solutions. Blood, shampoo, and even drinking water has a pH value. And speaking of drinking water, we have a student who has a question about it.
Hi, this is Rakhi. Can you please explain why rainwater is unsuitable for drinking?
Rainwater has a pH of about 5.6, so it is acidic. Drinking of this acidic rainwater may result in the malfunctioning of the body metabolism. Therefore, it is unsuitable for drinking. So I am sure all you people out there are not going to drink rainwater now, right? When I pick up an old book and see how it has got damaged with time, I feel upset. But why does this happen? This happens because fibers are made of cellulose. In particular, cellulose is sensitive to acid which is present in form of moisture. The 4 to 9% moisture commonly found in fibers is enough to allow acid-catalyzed hydrolysis to proceed. As hydrolysis proceeds over time, paper degrades. This is the reason why merely flipping the pages from an old book just tears it off. Salts undergo hydrolysis as well. As you know that salts are formed by the reaction between acids and bases in definite proportions, and the process with which a salt reacts with water to give back the acid and the base is called hydrolysis of salt. Salts involved in the hydrolysis can be of 4 types: salt of strong acid and weak base, salt of weak acid and strong base, salt of weak acid and weak base, and salt of strong acid and strong base. Solutions of salt of strong acid and weak base like ammonium chloride are acidic. Solutions of salts of weak acid and strong base like sodium acetate are basic. Solutions of salt of weak acid and weak base like ammonium acetate are neutral in nature. Solutions of salt of strong acid and strong base like sodium chloride are neutral in nature. So, can you predict whether a solution of sodium nitrite will be acidic or basic? Well, sodium nitrite is the salt of a strong base, sodium hydroxide, and nitrous acid, which is weak. Naturally, the solution of sodium nitrite will be basic. And on that basic note, I need to take a break. But don't go away, because we'll be coming back with Exam Decoded after this break. Welcome back. We have learnt a lot today. Let's do a quick recap. Today's episode defined the process of autoprotolysis or self-ionization of water. That is, in pure water, one water molecule acts as an acid and donates a proton, and one water molecule accepts a proton to act as a base at the same time. The ionic product of water is defined as the product of the molar concentrations of hydronium ion and hydroxyl ions. Its value at 25 degrees Celsius is 1 into 10 to the power minus 14 molar square. Also, pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration. We have studied the hydrolysis of salts, where the salt can be of 4 types: salt of strong acid and weak base, salt of weak acid and strong base, salt of weak acid and weak base, and salt of strong acid and strong base. And now for Exam Decoded. Welcome to Exam Decoded. As usual, we will begin with a rapid fire round. I will ask you 5 questions and you will have only 5 seconds to answer each question. And you get 1 mark for each correct answer. Here is your first question. NaCl is a salt of weak acid and weak base. True or false? Obviously, this is false. NaCl is the salt of sodium hydroxide and HCl, both strong base and strong acid. Next question. What is the pH of a solution whose hydrogen ion concentration is 10 to the power minus 3 molar? A 1, B 3, C 10, D minus 3. Answer is B. The pH of a solution whose hydrogen ion concentration is 10 to the power minus 3 molar will be 3. Next, solutions of salt of strong acid and weak base are A. Acidic, B. Weakly basic, C. Strongly basic, D. Neutral. The answer is A. Solutions of salts of strong acid and weak base are acidic in nature. Let's move on to another question. A solution with pH of 2 is A. Acidic, B. Basic, C. Neutral, D. Strongly basic. The answer is A. A solution with pH of 2 is acidic. Now the last but not the least. In pure water, the concentration of hydronium ion is always equal to the concentration of hydroxyl ion. True or false? The answer is true. In pure water, the concentration of hydronium ion is always equal to the concentration of hydroxyl ion. Now, let's take a look at how you have scored. If you got all 5 questions right, you are a high flyer. Your concepts are clear and you are quick and accurate in applying them. If you have scored 4 or 3, then you are an achiever. With more focus and practice, you could be a strong contender to score top marks. Consider yourself a learner if you scored less than 3. That means you need to revise more. For help, log on to www.topperlearning.com for interactive revision tips and practice tests. Ionization of water comes under the unit of equilibrium, which accounts for 6 marks, making it critical from exam perspective. This topic tests your numerical ability. This means you need to brush up your math skills and practice as many numericals as you can. You can expect short answer type questions for 2 or 3 marks like the following one. Calculate the hydronium ion concentration in a solution having pH 6.58. This is for 2 marks. The pH of the solution is given as 6.58. We have to calculate the hydronium ion concentration. We know that pH is the negative logarithm of the base 10 of hydrogen ion concentration. Writing the correct expression will fetch you half a mark. Next step is to substitute the value of pH in the expression. We get 6.58 is equal to minus log hydronium ion concentration. So, log of hydronium ion concentration becomes minus 6.58. So, hydronium ion concentration becomes antilog of minus 6.58. Writing the correct steps for calculations will fetch you half a mark. The concentration of hydronium ion comes out to be equal to 2.63 into 10 to the power minus 7 molar. Calculating the correct value of hydronium ion concentration and writing the correct unit will fetch you 1 mark. Since our aim is to get maximum marks, let's go to our expert who is ready with tips to maximize your score.
From examination point of view, numericals can be asked from pH as well as ionic product of water, and the students must take care while doing calculations along with the units, because if they write incorrect unit in the final answer, marks can be deducted. If hydronium ion concentration in any solution is greater than hydroxyl ion concentration, then the medium will be acidic, and if hydronium ion concentration is less than hydroxyl ion concentration, medium will be basic, and if both concentrations are equal, then the medium will be neutral.
Well, this is all for today, but I will leave you with some food, or rather water, for thought. Is the pH of tap water always 7? Why don't you test it and find out just what defines the pH of tap water? Happy experimenting. This is Devabrata saying goodbye.